So by definition, so this is our first one here. By definition, a matrix is in row echelon form if the leading entry in each non-zero row appears, the leading entry in each non-zero row appears blank, the leading entry blank, the leading entry in the preceding row. It has to be kind of the leading entry in each non-zero row appears below and to the right, right? So it always has to be like in the column to the right of. Yeah, so I think that's probably what we want here, right? Not ahead of, not in a row, in the row below. That's not good enough. I think we need in the column to the right of. So what do we agree on for number one? In the column to the right of. So second blank. All rows that consist entirely of zeros are grouped together at the bottom of the matrix. So I do know that one. Okay, question two and oh, these are nice. We can speed through this matrix stuff. Oh, I love matrix stuff. So, is this matrix in echelon form or not? Well, question three, that one's definitely not in echelon form. It's not in reduced row echelon form either. The issue we have here is this 3, right? So this is the leading number. It's not in the column to the right of the pivot or the leading number above it. Now, this one should be okay. Again, I'm a little bit hesitant on like what echelon form does and means for us. But I'm pretty sure everything should be fine here. Our zeros are at the bottom. We have a leading number, I guess, in each row and each column, so that seems okay. It was just the units, right? Like I was really just struggling with like the unit conversions. You can tell that I haven't taken chemistry since like I think I took chemistry in grade 11. That would have been in 2002. 2001, actually. So I took chemistry in 2001. That's the last time I've looked at chemistry. Find the augmented coefficient matrix of the corresponding system. Oh, this is nice. Oh, they've done awful things to us. How dare they? So if we agree that we want x's, y's, and then the constants, then the first equation, we can keep the negative 3x, but this 4y is going to have to come over to become negative 4y. And then this 4 is going to have to come over as well to become negative 4. The second row seems fine. We don't need to do any updates here, so we can input that as negative 9, negative 6, negative 4. And then we have 2x minus 5y should be equal to negative 1. So there's going to be our augmented. I mean, arguably physics doesn't either, but physics at least seems slightly more interesting. Find the reduced row echelon form of the augmented matrix. Ooh, so we're going to have to do some. Okay, we're going to have to do some work here. Are any of these, nothing's super nice here. These are disgusting numbers. Is there anything easy we can do? I suppose we could use the negative 2 to do some work. Wow. We're going to have to do some big-time Gauss-Jordan elimination here. Holy smokers. I take it back. This is a hard section. Can we get rid of this 10? So this is my first question. Can I get rid of this 10? And should I also maybe multiply row 3 by 2 to make things a little bit easier? I think I can reasonably take row 2 and add to it 5 row 1s. I think that would help there. And I think I'm going to multiply row 3 by 2. I'm going to turn it into a 6, and then it's going to be a little bit easier for us to do a little bit of work after that. So we have negative 2, 0, 5, 250. This should be 10 plus 10 for 0, 1 plus 0, negative 26 plus 25, so negative 1, and then 400 plus 5 times 250. What? 400 plus 5 times 250, so 1,650. And then we get 6, 0, times 2, so negative 16, and then 300. And again, now my goal here is to kind of make this into a 0, and we should be able to do that by taking row 3 and adding to it 3 row 1s. So I can keep row 1 the same. I can keep row 2 the same, I'm not changing that. And then row 3, so 6 plus 6 should be 0, 0 plus 0. We have negative 16 plus 15, negative 16 plus 15, and then 300 plus 3 times 250. So 300 plus 750 is 1050. Now, do they want reduced row echelon form? They do, reduced row echelon form. So we are going to have to get a final leading one here. So let's multiply by minus 1. We could also probably zero out. So again, I'm going to just kind of like work upwards. I can probably zero these out as well at the same time. So let's do row 1 plus 5 row 3s, and let's do row 2 minus row 3. That's going to be an interesting one for my brain to work on. Negative 2, 0. So 5 plus 5 should be 0, right? And then we need 250 plus, oh, this is gross, 250 plus 5 times 1050. So 5,500. Yikes. So for row number 2, we're going to subtract, so that should give me a 0 here. Negative 1 take away negative 1, and then we need 1650 take away 1050. It should be 600, so I'm happy with that. And then I guess the last step is just to take row 1 and divide by negative 2 or multiply by negative 1/2. That should fit the bill as well. So that should give us 1, 0, 0, 0, 1, 0, 0, 0, 1. And we'll have a 600, we'll have a negative 1050. And when we divide that by 2, what do we get? 25 and a 250, so 2750. 2750. All right, and that should be our reduced row echelon form. So yeah, we can just fill in all the numbers here with the 1s, 0s, and our constant terms. I'm not going to go back and do that. This is our RREF, so we are good to go. Question number 6. Solve the system by row reduction. Well, I guess the first thing we should do is we should get a augmented matrix. So that would be, let's make sure all of our x1s, x2s, and x3s are in the right spot. So 1, 3, 3, negative 6, negative 1, 2, negative. These numbers seem already a lot more reasonable than before. 3, 4, and 5. Okay, we can handle this. This is our first pivot, so let's get rid of these two numbers. So let's do row 2 plus row 1, and let's do row 3 minus row 1 to start. I am definitely going to need a lot more space, so let's get rid of these two questions. Whoop. Okay, we haven't done anything to row 1, so we can leave that the same. This should become a 0, right? -1 plus 1. We have 2 plus 3, which is 5. -6 plus 3. So -6 plus 3 is -3. And then -5 minus 6 more, so -11. 1 take away 1. We have 3 take away 3. Oh, that's handy. 4 take away 3. Beautiful. Wow, I could not have asked for a better... That is a fantastic row to get. So 5 plus, right? So it's 5 take away -6. So 5 plus 6, which is 11. So that's going to be my updated matrix. So the next thing that we probably want to do is I'm going to take... This is going to suck. I hate working with fractions so much. I guess I could multiply row 1. Maybe we'll do that. I can take row 1, then I can multiply it by 5, right? Wrong sign on the 2. Oh, the -2, so the one right here. Thank you for the catch, Omni.
QED.
How is that going to affect our matrix? So the error was here, right? That should affect this 5. So if that's the case, row 2 plus row 1. So negative, that's going to turn into a 1 then, right? Again, you love to see those 1s pop out like that. That's super nice. Yeah, I think that is fine, and that should be the only entry I think that was affected by my transcription error, right? Okay, so my next item here is I've kind of zeroed out the first column. I'm going to move into column 2. I have my leading one. So let's go ahead and let's take row 1 and let's subtract 3 row 2s. That should get us to 0 and 1. So 3 take away 3 times -3. So 3 plus 9, is that 12? 3 plus 9. And then -6 plus 33. -6 plus 33. These are weird numbers. 27. Okay, I guess it could be worse. We do have a final leading one in column 3, so the last 2 things we need to get as zeros are going to be these 2 numbers here. So we need row 2 plus 3 row 3s, and then we're going to need row 1 minus 12 row 3s, provided that my work is correct. If you do see any errors, please let me know. That should get us to 1, 0, 0, and then we do 27. Oh gosh, 27 take away. Wait, 27 take away 12 times 11. Woof. -105. That seems a little wild. 0, 1, 0, and then we do -11. So -11 plus 33. So that'll be 22. That one's more tame than the 105. And then 0, 0, 1, and 11. Okay, so that should give us our final answers here. So we have x1 is equal to -105, we have x2 is equal to 22, and we have x3 is equal to 11. So you can take those values, whatever you end up getting here, right? You're just inputting those numbers here rather than inputting a full matrix as your final answer. Ooh, a 4x4 system? Oh man, that's so gross. Okay, augmented matrix time. So we need an augmented matrix. Let's go 7, -16, 3, 8, -6. We need 1, 3, 2, 0, and 4. 2, negative 4, 1, 2, 1, negative
Is that a late
2.
or is that a early, depending on how you look at it? Your time, your call.
Fair enough. Yeah, I guess it could be early if that's your prerogative, but this is probably a spot where I definitely want to take row 2 and I want to swap it with row 1 so I can get that leading one up top. So I need 1, 3, 2, 0, 4. Let's move the 7, negative 16 down. And then we have 2, negative 4, 1, 2, 1, and negative 2, 3, negative 1, negative 1, and 4. All right, so you know what's up. We got to get these 3 entries to be 0. And I guess we can take row 2 minus 7 row 1s. We can do row 3 minus 2 row 1s. And we can do row 4 plus 2 row 1s. That should hopefully do the trick. So 1, 3, 2, 0, 4. Nothing changes there, but we should now get a 0. 7 take away 7. Negative 16 take... This is going to be disastrous. Negative 16 take away 7 times 3. So yikes. Negative 37 is what I get here. 3 take away 7 times 2. That's negative 11. That also looks nasty. That's going to stay as 8. And then negative 6. Negative 6 take away 28. 4 times 7. So negative 34. Woof. That looks awful. Okay, 2 takeaway. I'll take a look after I'm done with this this awful, terrible Gauss-Jordan step. So 2, we have negative 4 take away 6. 1 take away 4. 1 take away 4. 2 take away 0. We have 1 take away 8. And then this is an addition one. This one shouldn't be as bad. So 3 and 3 is 6. Oh, wait, it's a multiply by 2. So it's negative 2. So I have to multiply row 1 by 2. So 3 plus 6 is actually 9. Negative 1 plus 4. So 4 take away 1 is 3. Negative 1 plus nothing. And then 4 and 8 is going to be 12. Okay. These numbers look absolutely terrible. Like, there is not an easy number for us to pick. Maybe I divide this one 30, like I have a 37. What is this? I'm going to go on to Wolfram Alpha and I'm going to see what the reduced or echelon form of this is. This just says solve the system, though. I don't actually have to do reduced or echelon form. I could do backward substitution, right? So I could actually probably craftily make
circuits,
make up a
Keep
1
it
here,
that simple. They're like the equations of a system,
yeah,
all
okay,
interconnected.
I see it.
Just make sure they're wired up right.
You're playing Tomb Raider. Wow, I haven't heard that in a long time. So why don't we let's take row 3. Let's be crafty. Let's take row 3. Let's multiply it. No, let's not do that. Let's add to it row 4. And then I'm going to multiply that by -1 after I'm done. So I'm going to craftily make up a new leading one that I can use to do some work for us. So let's keep all of this the same. And let's go 0, -1. We're just going to add these together. So we get -1, 0, 2 take away 1, and then 12 take away 7. So 0, 9, 3, -1, 12. So now I have a new, when I multiply this, so let's take row 2 and let's swap it with row 3. And I'm also going to multiply row 3 by -1 at the same time. And that should give us a new pivot element where we can actually like do a little bit of work. So let's go 0, 1, 0, -1, -5. And let's take our 0, -37, bring that down. 8, -34. Now let's go 0, 9, 3. And what's all this about Penn actually doing math? What? Now we can get rid of this stupid 37, which has been bothering the shit out of me for like... Yeah, time to wipe out the rest, exactly. I mean, we're already here. I have a leading 1, so I might as well just try to get as many zeros as possible. That way the back substitution is a little bit easier. So let's go row 1, take away 3 row 2s. Let's go row 3 plus 37 row 2s. What the hell? And let's go row 4 minus 9 row 2s. Terrible. These are terrible numbers. Okay, 3 take away 3, 0. 2 take away 0, that's going to be 2. 0 take away -3. 0 plus 3. So that's 3. 4 plus 15 is 19. So that's going to be our new row 1. Oh man, look at this. We're like we're sneaking into these other questions. Oh, is it there's one question left? Okay, I know I'm getting like pretty close. I'm gonna need probably several more matrices here though. We're not even halfway. Damn. Okay, what do we get here? 0. This should be 0. This is gonna be -11 plus 0. We have 8 minus 37. 8 minus 37 is -29. No. -30, here's the fun one. -34 plus 37 times -5. Yikes. That one's terrible. -219. And then 0, 0. 9 minus 9, 3 minus 0. We're going to get -1 plus 9. So 9 minus 1 is 8. 12 plus 45. 12 plus 45 is 57. Sheesh. We can be sneaky here again, though. I could actually multiply... I could multiply this one by 4 to get a 12 and then add the -11 to it. Whoo-wee! So we can prevent fraction still. Yeah, 4x4 system by hand is not fun. This is like where I would probably step in and be like, let's just make them not do this and let's just have them do it on R instead. But I know the other people teaching this course with me are going to be like, nope. Which is fine. Times 4. So 3 times 4 is 12. 8 times 4 is 32. And 57 times 4, I have no idea what that is. 57 times 4 is 228. But now we can go row 3 plus row 4 and get a leading one. That's exciting. 0, 2, 3, 19, 0, 1, 0, -1, -5, 0, 0, 1. And, ooh, we might actually get some really nice cancellation here. 32 take away 29 is 3. That's a nice number. 228 take away 219 is 9. Ooh, we are getting some nice numbers here. That's quite lovely. Things are returning back to somewhat normal. Fishy on Sticks, hi! Reduced or echelon form when I hit the RREF button. Yeah, exactly. Man, it really just comes to me in the background. I chug through it, and then I just pop it back out. I just give it back to Wolfram, and that's how Wolfram solves all of their reduced or echelon form stuff. If I get the right answer, it's going to be such a big confidence boost for me today, especially after that terrible mixing question. Okay, we have our pivot, so let's do some column deletions. Let's do row 1 minus 2 row 3s, and let's do row 4 minus 12 row 3s and see if we can tame this 228 that we have. Okay, we are not changing anything in... Oops, that's a -1. In row 2, we are not changing anything in row 3. And in row 1, we're going to go 2, take away 2 for 0, 3, take away 6, and then 19, take away 18 for 1. In row 4, we're going to have 0, 0, we're going to have 12, take away 12, 32, take away 36, 32, take away 36, and then 228, 228, take away 12 times 9. It's going to leave us with 120. Okay, this actually isn't too bad. We should be able to take row 4 and we should be able to divide by -4 or multiply by -1/4. And when we do that, we get 1, 0, 0, -3, 1, 0, 1, 0, negative. We're almost there, chat, almost there. 1, 3, 9, 0, 0, 0, 1. What's 12? This is going to be -30? Is that what that's going to end up being? -30? Does that sound right? And with a final leading one, we get rid of these and get to a final answer. So we need row 3 minus 3 row 4s. We're going to need row 2 plus row 4, and we're going to need row 1 plus 3 row 4s. That should do the trick. I hope. I hope. I hope. I hope. Let the pain be over. All right, -30 doesn't do anything. We need to add row 2 and row 4. That's going to be the easiest one. That should give us -35. Row 1 plus 3 of these. So 1 minus 90? What? 1 minus 90 is -89. Okay. And then 9 minus 3 times -30 again. 99. I would have hated to have done all of that work just to get everything wrong. Wait. I actually need... Oh, no.
Zeta, no. Just bring yourself and your brain. We're not planning a physics lecture, so leave the books at home.
Wait, how does this... It only has square matrices. Can I just, like, put it in here and it knows what I want? Like 7, -16, 3, 8. Yeah, I guess I can input a full row of zeros, right? -2, 3, -1, -1, 4. And I'll just throw a full row of zeros in here. It should know what I want. Okay, give me weird large numbers for final answers, please. That's a transpose. Oh gosh, it's diagonalizing but not finding the reduced row echelon form. Please, RREF. Look at that, we did it! -89, -35, 99, -30. Holy shit, mic drop. There we go, we're good. What a confidence booster. A 4x4 system of equations solved by hand. God damn! I am good at my job.
God damn!
Alright, so given the following...
Zeta simple. Just pay attention and follow the instructions closely. Don't overcomplicate it.
Given the following augmented, give a parametrized set of solutions for the system. Use T to parameterize the free variable. So we do have to, getting to RREF is going to be helpful here. So let's do 14, -8. Let's just kind of take a look at what we have here. So 2, -1, 1, and 17. I could divide row 1 by 2, but that's not going to really help at all. So why don't we take row 1, and why don't we take away 7 row 2s? So in other words, I'm going to use 2 as my pivot element, and then I'll move it up into that top corner where it needs to be after. But let's just get rid of this 14 and maybe reduce this 128 a little bit and just see what happens. So 14, take away 14 should give me 0. Then I have -8 plus 7, which is -1. 2 take away 7. 2 take away 7 is going to be -5. And then here's the one I'm curious about. So we need 128 take away 7 times 17. So that's going to reduce that down to 9 for us. So now we can do a couple things. We can take row 2 and swap it with row 1. And I can take row 1 and I can multiply by -1 so I can get my second pivot. So that's going to be 2, -1, 1, 17. Bada boom. And then we got 0, 1, 5, -9. All right, so second pivot is in place. We can now get rid of this one. And what we were doing up above was getting rid of the 14. So anything I've kind of circled here in red are what I'm identifying as wanting to become a 0. They self-identify as 0 and really want to be noticed for being 0. So let's take row 1 and let's add to it row 2. And that's going to give us 2, 0, 6, 17 take away 9. What's that? 8? 17 take away 9 is 8. 0, 1, 5, -9. And we are almost there. We can now basically just divide row 1 by 2. And that should give us 1, 0, 3, 4. And 0, 1, 5, -9. It's not my first rodeo, fem. Let's say that. All right, so this pretty much gives us, if this is correct, which we will use Wolfram to double check, this should give us that x plus 3z is equal to 4. So that's the first equation. And the second equation is y plus 5z is equal to -9. And what we want to do is we want to let z be some kind of parameter, and then we're going to get a set of solutions that looks like x plus 3t is equal to 4, y plus 5t is equal to -9, and z is equal to t. So we're introducing that extra equation here so that we can actually get a full set of solutions for x, y, and z. So we'll have x, y, and z. X should be -3t plus 4, y should be -5t minus 9, and z should be t. So this should be our full solution set parametrized. And this is for t is any, for us, we're going to take t to be any real number. So t is just a parameter, and it allows us, if I pick a value of t, it gives me some information about x, y, and z. Let z equal z. Let z equal z.